All right, so in this problem right here, if you work through the steps to look at the graph, so your parent function, you have a base that's smaller than 1, so you're going to have a graph that comes down and approaches this asymptote. And so if we look to see what exactly happens here, so there is nothing that's added or subtracted outside this function. So there is no vertical shift. So what that means is that this asymptote stays the same. Okay, so y equals 0 is going to be your asymptote. Okay, if you look at the horizontal shifting, you see that the horizontal shifting is, so it's no vertical shift. The horizontal shift is going to go which direction, left or right? When you look inside the function, what value of x would give you a 0 here? A -1, so it's going to be to the left 1. So we are shifting to the left 1. So what I'm going to do is I'm going to plot the point -1 and find what the corresponding y would be. -1 plus 1 is 0, so this 1/2 to the power of 0 has a value of 1. Anything to the 0 power is 1 times 4. So what that means is it gets shifted and stretched way up here. So this is the point -1, 4. And is there, we see that this multiplier out front tells us that we are stretching this. There's no reflection because there's no negative out front. Okay, and so what we have is just this stretched graph. It's still going to have the same shape. Again, I could find the exact, do I ask you for the y-intercept here? Okay, so to find the y-intercept on all of these, you simply plug in a 0 for the x. So if I plugged in a 0 here, I get 4 to the power of 1/2 to the 0 plus 1, which is 1. 1/2 to the 1 is 1/2, times 4 is 2. So it's actually going to intercept right here at this point. Hey, it's still consistent with all of our rules. And so this is the sketch of the graph. And so if you're finding the left and right behavior, you can see where it's going. Left, it's going up or rising. To the right, it is going down. It is decreasing or falling, but it's approaching an asymptote. It's not going to continue infinitely. Going down, but it does approaches an asymptote. And again, that horizontal asymptote was y equals 0. And so your final one's the question that you have for the domain and the range. Well, the domain is all possible x values. So the domain goes from left to right. So the lowest x value to the left is -infinity. The highest x value as you move to the right, it continues infinitely without breaking. Okay, so the domain is going to be all real numbers, which will be true for all these exponential functions, whether they're growth or decay. Okay, the range, though, does differ based on what the graph looks like or if there's any reflection. The range are the y's, and they go from the bottom up. And so the lowest possible value is right where that asymptote sits, so 0, and it extends up. The highest y value extends all the way to infinity. Neither one is actually included, and so those would be the last pieces of information for that.